All right, so we are in the last half of chapter 6, and this is the last stuff we have to learn this year. We are in the home stretch, okay? The last little bit we're doing is inequalities, which we've kind of done a little bit of, okay? We've seen the symbols. We haven't really graphed them, okay? Dotted lines, solid lines, shading above, shading below, okay? That's what we're going to get into today. We're still graphing lines, okay? An inequality is similar to a linear equation, but it has an inequality symbol. I just talked about it. It's either going to be less than, it could be less than or equal to, right? It could be greater than, it could be greater than or equal to. Okay, the less thans look like L's. Okay, and these two are greater thans. Okay. A solution to a linear inequality, it's all ordered pairs, so remember the x, y's, that make the inequality true. So this time, it's not just 1 point, I'm talking you're not. I'm talking you're not. I'm talking you're not. This time, it's not just 1 point. It's going to be a whole range of things, okay? There's going to be an infinite amount of x, y points that are less than a certain number or above than a certain number, okay? So to determine if things work, we could plug them in, okay? Numerically, I can plug in points to an equation and see, does it work, okay? So if I was testing the point 2, 5, okay, I'm going to zoom in there. Does 2, 5, is that a solution to my inequality, 2x minus 3y is less than 15, okay? So to test that, I'm going to zoom in so y'all can see it better. You would plug in 2 for the x. You would plug in 5 for my y, okay? And then you would simplify. So 2 times 2 minus 3 times 5 is the same thing as 4 minus 15, which gives me negative 11, okay? Our original equation says it's going to work if it's less than 15. So is negative 11 less than 15? Yes. Okay, so this one works. Demario, turn it down. Okay, and then my next example, we're testing the point negative 1, negative 7. Now negative 1 is my x, and negative 7 is my y. So when we plug those in, 2 times negative 1 is negative 2. And then here we have negative 3 times negative 7, which is going to be positive 21. Okay? This is negative 3 times negative 7. The negative stays with the 3. Negative times negative, that's where your positive comes in. Okay? Negative 2 plus 21 is a positive 19. Okay? Is that less than 15? No. So that one is not a solution. So this is how we test points in an equation. Okay? You just plug them in. Does it work? All right. So how about our next one? Hold on. Let me do something real fast. Hold on. Okay, so those were the first two. Let's work out the next two together. 36. Here we go. All right, so now we have 3 and negative 4. So remember, 3 is x, negative 4 is y. It's also on the board, guys, if you need it. Okay, it's over here. Okay. So 2 times 3 minus 3 times negative 4 is what we're going to test. Okay? Is it less than 15? So it becomes 6. Hold on, what's negative 3 times negative 4? There you go, positive 12. And what is 6 plus 12? 18. Is 18 less than 15? No. Okay, So 3, negative 4 is not a solution to my inequality. And then we have the origin. The origin is always a nice point to test. Okay? The origin is always a nice point to test. And if I ever have to test a point, that's the one I'm going to test every time. Okay? We don't have to do this one, but again, I like it because I think it's the easiest. So now if my x is 0 and my y is 0, I have 2 times 0 minus 3 times 0. Is that going to be less than 15? Well, what's 2 times 0? There you go. What's negative 3 times 0? 0. What's 0 plus 0? Or even 0 minus 0? Is 0 less than 15? Yes. So, the origin is my favorite to test. Because when you multiply by 0 or add by 0, that's a concept that we're super familiar with. Okay? Are we good? I'm going to scroll back to where the words are. I could probably just write them. We good? We got these last two? All right. So now I want to test with a graph. Okay? So when we graph, we always want to write our inequality in y equals mx plus b form. Okay? We know that plus sign, or we know the equal sign. When it's an inequality, it's not equals anymore, right? It'll be less than, greater than, less than equal to, greater than equal to. The symbol there is going to matter, okay? If I have a less than or a greater than symbol, my turn, okay? We are going to use a dotted or dashed line, however you want to do it. I'm going to say dashed. We're going to use a dashed line when I graph it on my grid, okay? And then if I'm equal to, we're going to use a solid line, okay? So we would be either dashed up or dashed down. These would be solid up or solid down, depending on what the equation actually was for us to use. Obviously, a negative slope, it would fall down. Positive slope, we're going to go up. Okay. All right. Now, so to test, okay? All right. We're going to use, y'all done? There's a couple of things we're going to use, okay? We're going to either use our y-intercept to determine which side of the line to shade, or we can use the origin. Or plug in the origin. Okay? So we're going to locate our y-intercept to shade above or below that piece. Greater than, we shade above. Less than, we shade below the y-intercept. If you want to test a point, we're going to test the origin. Okay, I'm going to show you both ways, and then you're going to figure out which way you like better and which way you want to move on with. Okay, so it's totally up to you. Okay, when we shade, that shade is my answer. I don't have just one answer anymore. I have a whole region of points that are going to work. Okay, like in our example, we had 2 of those points that worked, right? So there's more than one answer. Okay. Ready to start working through it? All right, let's go to number 1. Here we go. We have y is greater than 1/3 x minus 5. The first thing I'm going to determine is, will this be a solid or a dashed line? It is going to be dashed. Okay? If it's missing the solid line, my line is going to be missing pieces of it. Okay? It's missing chunks. So this is going to be a dashed line. Okay? It's greater than, so we know it's going to be dashed. Okay? I'm still graphing my lines the same way I've been doing them. Okay? Where I'm going to, remember, this is my B and this is my M. Where do you begin your line? Where my B is -5. Good. So we're going to find the Y. Remember? We use our Y-axis to label our B. So there's -5. How are we going to move from there? If it's 1/3, there you go. We're going to go up 1 and over 3. Okay. Up 1 over 3. I could also go down and backwards. Down 1, backwards 3. Okay? When I connect these points, I'm not doing a solid line. When I connect them, this is where my dashes come in. So we're going to dash across. Like that. Right, this one's not solid, this one is dashed. Okay. Now, there are two ways to figure out if I'm going to shade. See how I have two areas? There's an area above and an area below the line. Hey guys, back to me please. Do we agree that I've divided my grid into two sections? One's above and one's below. One of those is my answer. Okay? There's two ways to prove it. You can plug in the origin, or you can use your inequality symbol. Okay? My inequality symbol is greater than. So when I think of greater than, do I think of up or down? Up. Okay? So we're going to be above my line or above the y-intercept. So here's my y-intercept. It's always just a safe point to use because we plot it anyway. Okay? So here's our y-intercept. Above that is going to be all of this. Okay? Don't shade dark, shade light. Okay? But this is all of my shade. That entire area is the answer. If I plug in any of those points into my equation, it's going to work. Okay? Let's also test. Okay?
So you always start at the top, or?
If it's greater than, yes. Greater than, you go above. Less than, we're going to go below. Okay? If you want to test a point instead, again, the origin is always a great go-to because they're both zeros, right? So instead of y, I'm going to put 0 greater than 1/3 times 0 minus 5. What is 1/3 times 0?
0.
Right, anything times 0 is 0, right? 0 minus 5 gives me -5. Is 0 greater than -5? Yes. Yes. So the origin is in my shade. That also tells you it's above. So you would plot that point and you would include that in your shade. All right? Okay. Cool if we move to number 2? Yeah? So number 2, we have y is less than or equal to -2x minus 1. So this time my symbol is less than or equal. So is it going to be solid or dashed? This time it will be solid. Because I'm less than, I'm going to shade below our line. So we'll find the y-intercept, which we graph first anyway, and we know my shade is under it. Okay? So now let's graph my line. Where do we start this line? We begin where we have a y of -1. So we're going to begin right here. Okay? This -2 is my m, or my slope. It's how we move. So how do I move to my next point? Good. We're going to go down 2 and forward 1. We go down because it's negative. All right? So down 2 over 1. And to go backwards, I can go up and back. Okay, and we've already determined that we can connect with a solid line. So I can connect these with the normal lines that we're used to. All right, so we said that having less than means we get to shade below. So find my y-intercept, which was the first thing that you plotted, right? And we're going below that point. So that means we're going to shade everything on this side of the line. Okay. If you were to test the origin, would it be in your shade? It should not be in your shade. It should not work. Okay? If I tested my origin, I would have 0 is less than or equal to negative 2 times 0 minus 1. 0 less than or equal to 0 minus 1. Is 0 less than or equal to negative 1? No, it's actually greater. So that proves that the origin is not in my shade, which I didn't have it. Right? This was not a solution, so it was not on the shaded side. Okay? Again, testing a point is extra if you want to do it. You could just test the point, you could just use your sign, or you could do both of them together just to double check. How do we feel? So the shading is all the points that will make my equation true. So like if I were to take anything in the blue and plug it in like we did earlier, they would all be yeses. Yeah, they would all work. They would all be yeses. Yeah, what's up? Okay. All right, let's go to number 3. How is number 3 different? Yeah, the sign is different, and it's not y equals mx plus b. It's in our standard form. So we got to move stuff. Okay? So we're going to have to move some stuff over. All right, we have 5x minus 2y is greater than 12. Okay? So to get my y by itself, we've done this a million times, guys. What do I have to move out of my way? I want y to stay where it is. So what do I have to move? The x, the 5x. How am I going to move 5x to the other side? Subtract it. Good. Okay. I'm left with negative 2y. We still have greater than. Negative 5x leads the other side, and I still have positive 12. Okay? That does not change to a 7 because 12 does not have an x. Okay? From here, I still have a negative 2 attached to my y. So how am I going to get rid of that negative 2? How is negative 2 attached to y, first off? It's multiplying. So how do I undo that? Divide.
Oh, yeah, you can divide.
All right, something very important just happened. We just divided by a negative number, and that is going to flip my sign. This is a big deal. When you divide by a negative number, it is going to flip your sign. So you now have y is less than. Your sign is going to flip because we divided by a negative number. Ooh, what just happened? Okay. Our sign is going to flip, and that is only because we divided by a negative 2. Okay? Negative 5 over negative 2 is going to be positive 5 halves x. Positive 12 divided by negative 2 gives me negative 6. Okay. Your sign flips when you divide or multiply by a negative number. Your sign flips when you multiply or divide by a negative number. We've already done this before. This is not new news. When I solved these earlier in the year, the same thing happened. Okay? Sign flips when you multiply or divide by a negative number. Okay? Your sign flips when you multiply or divide by a negative number. Okay? Now that we're in y equals mx plus b, now I can do what I did for number 1 and number 2. We had some extra work we had to do beforehand. Okay? Now my symbol is less than. So will this have a solid or dashed line? It's just less than, right? We're not equal to, it is not solid. Okay? This will be a dashed line. And are we going to shade above or below the line if I'm less than? If I'm less than. If I'm less than, we're going to shade below. Less than and below both have L's. You're going to go down. Okay? So where am I going to start this line? What's the first point we're going to mark on my line? -6. Thank you. 2, 3, 4, 5. Okay? And this first one I always make like extra big because that's what we're going to have to use later. Okay? From here, how am I going to move? Yeah, up 5. Good. Leland, you have to go to the bathroom. I don't have any. Up 5 and over 2. Up 5 over 2. Up 5 and over 2. Okay. I'm going to connect these with a dashed line. Like that. Okay. And we said we were shading below, correct? So find the y-intercept and go down. So do you see how we're underneath the line? So I need all the pieces that are going to be underneath my line. Okay. Okay. If you were to test the origin, you should get something false. You get 5 times 0, which is 0, right? Minus 2 times 0, which is 0. So it ends up being, is 0 greater than 12? Hey, is 0 greater than 12? No. So that proved that the origin is not in the shaded region. It became 0 minus 0, which is just 0. 0 is not greater than 12, so it's not in the shaded region. All right. Ready to move on? Number 4. All right, here we go. Number 4. I have x minus 4y is less than 8. It is not in mx plus b form. I have to move my x. How do I move my x? Subtract. Good. We subtract it. I still have negative 4y on this side. Less than. Negative x is up front. Positive 8 is next to it. Okay, 8 was already there. We're just moving negative x in front of it. What do I do with my negative 4? Yes, divide each piece. And we have to flip the sign. Good, yes. we have to flip my sign so that it becomes y is now greater than negative over negative is a positive. This will be positive 1/4 x. 8 divided by negative 4 gives us negative 2. Okay. We divided by a negative, so that means that my sign flipped from less than to greater than. When I graph this line, will it be solid or dashed? Dash, good. We're missing the equals to. We're going to be missing pieces of my line, right? Am I going to shade above or below with a greater than symbol? We're going to go above. Good. Okay. Where is this line going to start? At -2 on the x-axis or on the y-axis? On the y-axis. So right here. Again, make your y-intercept an extra big dot, because we're going to definitely need that later. How are we moving from this point? Yes, up 1 and over 4. Good. Up 1 over 4. You could also go down and backwards. It's a dashed line. All right, so above or below? We said above, right? Find the y-intercept, go up. So if I went up, that means that's all of this. All of this is in my shade. Okay. If you wanted to test your origin should work, right? Did we shade in the origin? Yeah, it's in there. My origin is definitely in my shaded region. So if I plugged it in, it should work. So 0 minus 4 times 0 is just 0, right? Is 0 less than 8? Is 0 less than 8? Yes. So 0 minus 4 times 0 is just 0. And is that less than 8? Yes, it is. So if you wanted to test your origin works out, and it's in the shade, so you were correct. What's up? Hold on. All right, I want to skip to number 6. Actually, I want to do 7, 8, and then come back. I definitely want to make sure I get 7 and 8 taken care of first. After I do 7 and 8, and they'll be fast, so you can go. Okay. All right, so 7 and 8. And then if we have time, we'll come back to the other two. Okay. Why do you think I want to do 7 and 8? Yeah, I only have one variable, right? So what are we going to look for? Remember our Hoivux stuff going on? Yes? So I heard solid already. Why did you jump to say that this line is solid? There's an equals to. Good. So we can definitely label that. It's going to be a solid line. And are we going to shade above or below it? Below. Good. Good. Okay. So y equals, is that a hoi or a bucks? It's a hoi. So what kind of line is it? Horizontal. Good. Hoi lines are horizontal. So we find where -4 is. There it is. Solid line. All right, and are we shading? We said below, so we're going to go under it. The next one is a little sneaky. Okay, let's start it how we've been doing all the other ones. I have x is greater than 7. So first off, solid or dashed? Dashed, good. Above or below with greater than? Above. Is this a hoy or a vux? A vux. And vuxes are vertical, correct? So we're going to find where x is 7. We're going to dash through it. So how is this sneaky? There really is no above and below, right? Don't vertical lines cut in half left to right? So instead of above, where are we really going to be shading? The left, which one? The left or the right side? The right side. Okay, think about it. Where my x's are bigger than 7. Isn't that 8, 9, and 10? Aren't those bigger than 7? So it makes sense that we're on the right side. So that's the only time we have to do left versus right, is when we have a vux. Okay? Otherwise, we stick to above or below the whole time. Isaiah, you can go to the bathroom. We are going to go back to number 6. All right. What's up? Oh. All right, let's go back to number 6. All right. 3x plus 2y less than 0. All right, I can't make any decisions until y is on its own. So what do I have to do to get it by itself? Subtract what? Yep, subtract my 3x to the other side. I'm going to put the positive 2y. We have less than. Negative 3x got moved. And I still have 0. Do I have to write plus 0? No, but if you want to, are you wrong? No, it's fine. Sometimes it helps to write it there, so you don't think you're missing something. Is y by itself? Nope, what I gotta do? Divide by 2. Divide it all by 2. Does my sign flip? No, we did not divide by a negative. Finally, the sign stays the way it is. So y is less than negative 3 over 2x. And then 0 divided by 2 is just 0, right? So if you want to put plus 0, go for it. All right, so now we can make decisions. Will this line be dashed or solid? This line will be dashed. Are we going to shade above or below it? We're less than. There you go, below the bottom. Good. If it looks like an L, it's going to be less than. Okay? All right. Where am I going to start this line? At the 0. Good. How am I going to move from here? Good. Down 3 and over 2. I'm going to zoom out a little bit so we can see the rest of my graph. Down 3 over 2. I could also go backwards by going up and back. So up 3, back 2. Up 3, back 2. Okay. We already decided this is going to be dashed, so I'm going to dash across. And are we shading above or below? We said below, right? So find my y-intercept, go down, so we know where that half of my line. So all of this. All right, one more. We can do this. One more and then we'll do stamps. Good job. Do we like this? Is this okay? Ish? Okay. Okay. You've done worse, right? All right, let's go over to number 5. We have x minus y is greater than or equal to 8. Okay? Is it in y equals mx plus b form? No. So what am I going to move over first? The x. How am I going to move it? Subtract, yep. So I have negative y left over here, greater than or equal to. Negative x is first, and then after it is a positive 8. Is y by itself? No. What's still attached to it? A negative. So how do I get rid of a negative? Yeah, divide each piece by -1. Does my sign flip? Yes. Our sign is flipping. Woo. I don't know why it keeps doing that. Okay. My sign is going to flip because we divided by a negative number. Negative x over -1 is just going to be positive 1x. And then 8 over -1 gives me -8. Time to make decisions. Will my line be dashed or solid? My line this time is solid. Are we going to shade above or below it? We are below this time. Less than is below. If you could put your fingers over that and it looks like an L, it's going to be less than. Right? Right? That would make an L. So it's going to be less than. Okay? Where does this line start? At -8. How am I going to move? There you go. Up 1 over 1. Fun fact, that means it's also going to cross over at 8 over here. Did you know that little shortcut? If your slope is 1, those are the same number. Up 1 over 1. It is a solid line. There we go. Find that y-intercept and go below. So it's going to be this bottom corner. Good. If you wanted to test the origin, you could. You would get 0 is greater than 8, and that's not true. So the origin is not in your shaded region. Okay. All right.